We are back with problem 3 in homework 2, and I've updated this problem. Or actually, I replaced the original one that I had there. I hope no one's wasted a ton of time trying to solve it. But here we got this combination of pulleys and blocks and even this like kind of collar thing that's on a rail that rides up and down. And it starts from rest, and everything moves with a constant acceleration. The relative acceleration of block C with respect to B is 3 meters per second upwards. All right. And the relative acceleration of D with respect to block A is 5 meters per second squared downwards. And we want to find the velocity of C after 0.5 seconds and the change in position of D after 0.75 seconds. So that's what we're working with. And a little confusing to start with, right? Well, we have to try to organize this and try to see what we know and try to find a path forward. So one of the first things to do is to draw ourselves a lovely datum. Right, that's a good spot to start from. And so I'm going to have my reference to A be right here. I'll call that YA. And I'm gonna, because it can't really see it very well right here, I'm going to cross over there. It's not very good draftsmanship, but hopefully we'll be able to see. There's YB right there, and then YD, and maybe I need to extend my datum, don't I? Extend my datum down, and then go YD right down to there. And let's see, what else do I need? I need C. That's easy enough. YC. Look how much I've worn out my ruler. I have a fresh one here. I like this. I like the one that says see through, but I don't know. Oh, there you go. See through. See. So there you go. It says see through. I guess on that side. The see through the Westcott B55. That's good. Excellent ruler to be using. That seemed to be a non sequitur. All right, so let's see. Let's write out what let's do this thing. All right. Well, we see that this is one cable right there, right? But there's a second cable. So let's go L1. Let's do the first cable. So looking at this right here, we have 2 times YA. And then let's see. Now we want to figure out this length right here. Well, that one right there looks like it's 2 times YB. Let me double check that I got that right. So this is cable 1. Yep, that looks like 2 times YB. And then it comes, okay, so there's 1 and 2. And now this doesn't matter. That's constant, always stays the same. And then we have this length right here. So that's plus YC. Easy enough after you see it get done right there. But there's a lot of stuff going on right here. But if you just trace through, yeah, look, that's Y. There's 2 times YA, 2 times YB, plus YC. So we take the velocity, 2 times VA, plus 2 times VB, plus VC, after we differentiate that, and the length goes away. And then we can also say that 2 times acceleration of A, plus 2 times the acceleration of B, plus the acceleration of C, right? So there you go. There, and now we're going to go with the length of the other cable. They're just simpler here, but let's make sure we get this right. That's going to be YD minus, let's see, let me double check. Okay, so we're going to have this length right here. That will be YD minus YA. You agree with that? Now there's a constant thing in here, but we could just get rid of that, right? So it's going to be YD minus YA. Now we're going to go with this guy right here. It's going to be YD minus YB. Yes, there's stuff right in there, but it's really this all constant right there. So that's going to be plus YD minus YB, or 2YD minus YA minus YB. So if we differentiate that with respect to time, we get 2VD minus VA minus VB, right? And 2 times the acceleration of D minus the acceleration of A minus the acceleration of B. A lot of equations to do. All right, so we can also write out what these things represent, right? So we're going to say, and these are all just relationships to what's going over there. We can now take a reset and say upwards is positive, right? So that's what our signs are going to say. It's confusing because we always draw them down this way. We're just trying to find their interrelationships. Now that we have that, we can go ahead and do a reset of our coordinate axes, and we're going to say up is positive, just as you would expect. So the acceleration of C with respect to B, and I'm just going to, well, I could keep the vector hats on there. It's going to be the acceleration of C minus the acceleration of B is going to be equal to 3, positive 3, right? And we could also write the acceleration of D with respect to A is going to be acceleration of D minus acceleration of A equal to -5, right? Because it's going down. The difference is downward. Let's see, double check I got everything correct. So what we can do is we can substitute these things in now, right? So we're going to and sometimes it helps. I think because I had a lot of acceleration things going on, I'm gonna call that equation 1, and I'm gonna call this equation 2. I'll call this equation 3. And I call this equation 4. And I only mean this part of it right here. I'm ignoring that part right there. So what we want to do is substitute. Did I spell that right? I don't know. Substitute. That's a weird looking word. All right. We're going to substitute 3 and 4 into 1, right? Because we have, so maybe I'll actually, let me go back for a second here. And let me just say, we want to put this into 1. So let's solve for A and let's solve for B, right? So we have acceleration of B is going to be equal to, that's going to come over here. So it's going to be AC, and that's going to flip over here, -3. Did I get that right? And I'll call that equation 3. And then I want to solve this for acceleration of A. We'll say, we'll bring over here and bring over here, so it's going to be acceleration of D plus 5. You can check on that, right? Sure. Whoa, wait a minute. I just did that wrong somehow. Wait. Oh, I see. I didn't reset it over in my other thing over there. Is that going to cause trouble for me? I'm double checking something. I think I'm going to be okay. So now I'm going to substitute 3 and 4 into 1. And I will say that, is that going to be okay? Yeah. So we go 2 times the acceleration of C minus 3, right there, plus, oh, why did I do that? It doesn't matter, but I should do this correctly. All right, it's this guy that we're substituting here. So that's 4 into there, AD plus 5. And then 2 times AC minus 3. All right, and then plus AC equals 0. And what I've done now, at least I've reduced this down to so we have 2AD plus 10 plus 2AC minus 6 plus AC equals 3. So I have 2AD plus 3AC plus 4 equals 0. Let me look and see compared to what I've previously done, because I made a sort of a change right there. Yeah, I think everything's going to be fine right there. All right, now I substitute 3 and 4 into 2. So I'm going to put this back up into here. So I'll have 2 times AD. Oop, nope, I'm going to leave that the same. I'm going to leave that as AD. Leave that as 2 times AD. That's fine. But I'm going to substitute for the negative this guy in for there. So it goes negative, let me just put them in there. I don't have to put these parentheses. Negative AD minus 5 right there. Did that right? Yeah, in there. And then for here, it's going to be minus AC plus 3 equals 0. And by the way, I might want to call this now, this one up here, like equation 5. And then when I get done with this, I'll call this one equation 6. It's just, the means of keeping track of a whole lot of stuff going on. There's a lot of stuff going on. Wait, did I have D? Yep, so it's just going to be AD. It's going to end up being negative 2 right there, right? Minus 2, yeah. And minus AC, right? Yeah, minus AC. And I might have wanted to, up here in this one, in hindsight, make this equal to negative 4, right? And then down here, we want to set this, is going to have negative 5 in this, so that's going to be go on the other side, it's going to be equal to 2. And that'll be equation 6. Let me double check on this right there. Yeah, I think it's going to be fine. All right. So, these are the can I find the accelerations in here? Oh, I can solve 5 and 6. See, 2 unknowns, 2 equations, right? Solve 5 and 6 together, right? So, if let's probably easier to make that one into AD is equal to AC plus 2, right there, right? And substitute that into this one right up here, right? So we'll say 2 times AC plus 2 times 2, right? Because we're sticking it into right there, plus 3AC equals negative 4. And I think I can solve for AC now, right? So, that's good. No, okay, that's good. It's going to be negative 4. It's going to be negative 8 right over here, right? It's going to be negative 8, and we're going to have 2 and 5, so we're going to divide negative 8 by 5, right? So we'll get a negative 1.600, and that means because I did all the reset, that means that's going to be downwards, and these are meters per second squared, right? So now I have to go to a new sheet. They'll make more paper. We can get more paper, so don't worry about that. Let's see. Let's put our heading on here. So this is the 5th page of this. Oh, I didn't finish my name. That was weird. Something must have distracted me. And F21, ES211. And this is homework 2. this is 3 continued, dot, dot, dot. Maybe it's only 3 dots, right? That'd be correct. And let's see. Okay, so we found AC. We could find AD then. AD is then going to be, all right, so it's going to be right here, AC plus 0.2, right? So AC plus 2, I said 0.2, I meant 2. So that's going to be negative 1.600 plus 2. So obviously that's going to be 0.8, right? No, 0.4. Math is hard, kids. That's going to be 0.4 meters per second squared. And so that's going to be upwards. D is upwards. And let's see. We were trying to solve for velocity of c at 0.5 seconds. It starts from rest. So the velocity of c is going to be velocity of c. Oh, I decided to call this 1. So the velocity of c, 0, plus the acceleration of c times time 1, right? And we said in the problem that we were looking at 0.5 seconds. So we'll call that t1. So we might even solve this as 1. And this will be 2 because I had that as 10.75. All right, so the velocity of c1 is going to be start at 0 plus this is a negative 1.600 times our 0.5. So we end up with a negative 0.8 meters per second squared. So that's not squared, that's velocity. It's the velocity, meters per second. And then for this, that's the answer for part A. And for part B, we need y of d right here. So we say y of d2 is equal to yd0, right? Plus the velocity of d, 0, I guess there, times t2 plus 1/2 acceleration of d, which is constant, t2 squared. So this right here is actually, you could bring this over, but it starts at some reference point right here. So we just say delta yd2 is going to be equal to, that 0 times our 0.75, and then plus 1/2 times our acceleration of d, which was the 0.4, and then times time squared, 0.75 squared. So what do we get? 0.4 times 0.75, square that, 10 times it, and divide it by 2. So I get equals to 0.1125 meters. And I think it's going upwards, right? It's positive, so it's going upwards. Let's see this over here. All right, so we get the answers. A is going to be velocity of c1 is going to be equal to 0.800 meters per second downwards. And B, we're going to have delta y d2 equal to 0.113 meters up. And I guess I could make that a vector too. I don't know if I did that in the other problem where I had a delta y going on. Put a nice box around there so we can identify that's the answer. All right, so we've done homework 2, and once again, let's do a little reflection on what's taking place and how we went about this. We were just very systematic about trying to figure out what the lengths of these were, and that allowed us to get the dependent motion of the velocity and accelerations. We were given some acceleration information, so we were able to turn this around and substitute it back into there, and we essentially had 4 equations and 4 unknowns. That's basically what we were looking for. And then we were able to find what these were from constant acceleration relationships. So there we go. Yay for being done. And if you were able to get all this way through and get the answer on your own, congratulations.